Hello everyone. In today's video, we're going to be talking about Physics 252, Week 1, Problem 3. In this problem, we are tasked with finding the velocity and direction of a car and a truck after they collide. So given in this problem, we have the truck's mass, which is quite heavy, and I want you to remember that as we go through the problem. And it is traveling through the south or negative y direction at 20 meters per second. And of course, this is the speed, not the velocity. So it collides with a car, which is much lighter mass, and it is traveling in the positive x direction. And I think this is a typo in the problem because west is not the positive x direction. It is actually the negative x direction, and we can see this on a coordinate plane in which the axes are labeled as a compass. So the positive x direction would actually be east, not west. So I'm going to go ahead and assume that this problem means east throughout the rest of the problem. So it is traveling at 30 meters per second here, and it notes that the car and the truck stick together and move as a single unit. And if you remember from our lecture this week, this is an inelastic collision, as the masses conjoin after they collide. So given that it is inelastic, we can remember our equation for inelastic collisions here, which will give us the momentum before and after. So we have this equation, and then I've also decided to include this equation here, which is the magnitude or length of a given vector, because the way that we will be solving this problem is using vectors. And we can kind of think about this as well as if we think about these masses moving kind of as velocity vectors here and here, we can kind of project what their vector might look like over here, and then our direction is going to be this angle theta right here, which we are trying to solve for. So what I've done is I've written out the m1v1 and m2v2 for both the car and the truck over here. And since the car is traveling in the x direction, I've denoted it as being I, which commonly stands for the x direction in unit vectors. And here we have our j direction or y direction for our truck, and here we have our masses added together and our velocity vector over here. So when solving this equation, we can just go ahead and simplify and then go ahead and divide by the two masses here for each, and we're left with this vector right here. And using this vector, we can calculate its magnitude with this equation that we were talking about above here. So this vector right here actually gives us a magnitude of 17.996 meters per second. And of course, this is the magnitude of the velocity, so it doesn't have a direction. But if we think about our collision here, and if we think about our much, much greater mass of the truck, we can project that it is going to be traveling in the negative direction, and hence our velocity would be this negative 17.996 meters per second here. So after we find the magnitude, we can use this same vector here to solve for the angle from the x direction in this case, because that is how I've chosen to set up the problem. We could also have put theta here and just rearranged our numbers, but using the inverse tangent, I'm taking our opposite right here, which is opposite side length, which is 17.65, as we see in this vector, and our adjacent vector here, or excuse me, adjacent side length. And when we calculate this out, we get 78.69 degrees in azimuth, which is the degrees measured from north in this direction. The angle is 168.69 degrees. The compass quadrant bearing would be south 11.3 degrees east, and our degrees from the x-axis is 78.69 degrees. So thank you very much for watching, and I hope you found this video helpful.